there. This is Avi Verma here. I've been trying to catch up and play with EC2 Container Services for the last few days, and I have found some very interesting and useful information that I would like to share with you today in this session. Um, First, I'm going to cover briefly all the key features of container service, followed by some explanation on the key terms involved. And then lastly, I'm going to show you a simple example that I've been playing with. And lastly, I'll share with you some of my thoughts on the architecture related to EC2 Container Service. So here is a list of all the key features. So it is simply a container management service for managing our Docker containers. And it is highly scalable and performance oriented. In fact, we can churn and manage thousands and thousands of containers rather quickly. And ECS allows us to run container-based applications on a managed cluster using EC2 containers, as rather EC2 instances. And as Amazon claims it, and I would tend to agree based on my limited play and experimentation with the service, is that it can eliminate the need for us to install, operate, and scale our own container-based service. Lately, Amazon has included a nice, neat, and functional management console through which we can launch and scale, schedule, and stop Docker containers right from within the management console. And if we prefer, we can also use JSON format to achieve the same thing, again, right from within the management console. And I'm going to show you how to do that briefly. And lastly, and this is the best part in my opinion, is that ECS is very tightly integrated with Amazon features like security groups, elastic load balancers, EBS volumes, and access management roles. So what are some of the key terms involved with ECS? So first, what is a container instance? Well, in a simple language, it is an EC2 instance in which a Docker daemon and an ECS agent are running. In fact, ECS agent itself is a Docker container. Container instances are used to run related containers, Docker containers. So if you look at this representation in my technical diagram, is that this is what a container instance may look like, with Docker daemon and couple of tasks running, and each task is representing a bunch of related or linked Docker containers. So coming back, and by the way, Amazon provides a few standard images which we can use to launch a container instance with the Docker daemon and an ECS agent. And once we create a container instance, it has to be registered and be part of the cluster so that we can scale up and down as needed. And this little software, ECS agent, is how we manage these container instances from the ECS management console. The next term is task definition, and it's simply a way to define our resource requirements not only for the the containers that are going to be part of a container instance, but also any volumes that we may use as part of this task definition. And a task definition represents a group of linked or rather associated Docker containers that are supposed or intended to run together. And a task is simply a realization or instantiation of these task definitions. Coming to a service, service lets you run these tasks, and you can schedule them, and you can mention how many copies of a particular task would you like to run in your cluster. Cluster, on the other hand, I'm certain you are quite familiar with, is in my mind is simply an abstraction of to represent a group of container instances. And cluster can span across various availability zones. So this is how we get the high availability in our apps. And cluster can also represent and provide a pool of resources in terms of storage and volume and so on. You can technically start an empty cluster, and as needed you can scale up or down. So this is this is a list of all the key terms. Now, going to an example of how a typical task definition may look like. And by the way, I have taken this example from Amazon. So to your left, you see a description of a container called WordPress. And the Docker image that it is using is this. And there are some resource requirements given for this container in terms of CPU, memory, and others. This particular term, essential equal to true, basically is telling ECS that if this container dies, don't bother, just shut down the container instance and create a new one. So essential true represents the essence, the importance of this container. Link, you may be familiar in Docker world, represents the linked container. So in our case, this is linking to a container called DB here to your right. This is the entry point, which should be the first thing that this container does after being created in this container instance. And you can also define your requirements for your environment, and I have left it blank here. And here is an example of your port mapping. So in this case, this container is going to use port 80, and which is mapped to the host port 80. Now coming to this, again similar things, and essential is true here as well, which means this container is also a must for us to succeed. And the way I have visualized these two containers is in this diagram. So these are running under container instance represented by this task, and here is a representation of these two containers, WordPress and DB. And as you can see, ECS agent software is running as well, and that's how we can manage this container instance from the ECS console. Moving on, this is another example of two related containers called Simple Demo and BusyBox. And again, I've taken this example courtesy Amazon. Here, the only difference from this and this example is that I have shown one shared volume represented by mount points. So there is a volume called my dash volume, and to your right, BusyBox container is leveraging the same volume as represented by this line. It says volumes from, and use the source container called simple demo, and use the same volume called my volume. And as you can see in the visualization, I have added one shared volume between these two containers. So that's the only difference. Now here is a screenshot that I took from ECS on how a typical service is going to look like. So here a service is called simple web app is wanting to create 5 tasks using this task definition. At the moment, though, there are only 2 tasks running, as you can see here, and there may be some reasons why it hasn't reached to our desired count. In my case, I did not have enough EC2 instances available because it's a demo. But you could create a load balancer or auto scaling definition which can scale this quickly to 5, and I'm going to show this in an example later. So this is, well, actually let me come back to this in a minute. Let me show you some of these things in a simple example. So here I have a task definition, and by the way, I am in this part of Amazon services, EC2 Container Service, and that's how I reached to this screen. So I have clicked on this link called task definitions, and I have created this definition. I have another revision, so it's called sample ECS AVI revision 1, and this is where you see a list of related containers, in our case simple app and BusyBox, represented by these images from your Docker Hub, are part of this task definition. And we also have a shared volume called my volume, right? And this is where I was talking about JSON. If you choose to, you can do things in a JSON format. So this nice looking GUI, and by the way, if you try to create, so let's try to actually create a new task definition so you can see ECS GUI, and this is where you give a name. So you can say test ECS task, and this is where you can add your Docker images and define container name and bunch of other things. If you go further down, ECS allows, so here not only can you put your name and Docker image and memory and ports, but you can also define your environment variables, the command that you would like to run, the working directory, and network settings, and DNS and search domain, and etc. And you can also define your storage and logging requirements in this management console. So this is really quite useful and easy to define these things, right? You can define your security requirements. You can limit resource requirements for this task definition, and you can also optionally provide Docker labels. So a lot of options available for us, and again, if you choose to, you can do the same thing. If I go back and click on it, you can do the same thing in JSON format. So I'm going to stick to what I have created and excuse me, and if you click on this container, here's a snapshot of all the things that we have defined for this container. So port mappings, environment variables, and other things including volumes and mount points. Similarly, you can deep dive into the second container and look at various settings yeah, available for this container. So once you do that, you can review, and basically after you have created this task definition, you can run it ad hoc by using this feature. But most of the time though, applications are everlasting, right? So in that case, we need to define a service, rather create or update if you have an existing service. So this is where you define your new service and give it a name. So you can say test ECS service for demo, and it says which cluster, and I have one. By the way, Amazon comes with a default cluster, so that's the one I'm using. Which task definition to use, and how many tasks would you like to spun immediately. So you can say number of tasks, and if you would like to use load balancer, and I'm recommending that we always use one, and I have defined one already. And by the way, so let me go back to cancel this for a minute and go to dashboard, my dashboard, and this is where I have defined a load balancer, which I'm going to use with ECS. So, and I have included for actually one is out of service, but I had included 4 EC2 instances which are going to become container instances in the context of ECS world. And if you choose to, you can also create an auto scaling group right here. As you can see, I've created one sample auto scaling group, and I have given desired count to be 4 and max it out to 5. Obviously in real life situation you'll have much larger number here, possibly in thousands. So I wanted to quickly show you that auto scaling comes handy when you are working with ECS, and obviously you should have your security groups and things like that already defined. So going back to EC2 Container Service, again, let's go back to our task definition and try to create a new service, right? So demo ECS service, a number of tasks that we would like to run, and select your load balancer, and here it lets you associate or create an IAM role, because essentially in order to run a service you need a role to allow ECS to access your EC2 instances and the cluster. So I'm going to use the one that I've already created called ECS service role, and then create the service. So that's how you create a service. And now it says, well, you have created a service and you are asking to have 2 tasks for this service, but right now it's not running any, most likely because I don't have, oh well, it's trying to churn one up. So it says, well, I'm trying to create one. As you can see, one is pending. Let's see if we can get one more. Well, not, because I know I have only 4 instances available and they are being used by other service. So for now, let me just go back to the service and try to stop it, actually update one. And before you can stop, you have to bring the number of tasks to 0, obviously, and then you can go back and let's try to delete the service. Okay, and I'm going to show you the one that I've already created. Actually, there are two, one using ELB and other one without using ELB. So let's take a look at this service. So here, as you can see, I have put a desired count to 3 and they're already running. So if you try to create, let's go back, and if you suspect that you need one more task, meaning you need more horsepower. So by the way, here are all the EC2 instances that I have, and these are what are called container instances for ECS. And so if you select one here, oops, sorry, I wanted to modify one. So let me select the service, update one, and say I want 4 tasks running. Now desired count is 4 and we have 3 running, so we should, well, ECS should create one more. See, it's trying to create, it says pending count 1. If you go back to tasks, so it's trying to create one right away. It's pending. If you try to refresh, you should see one shortly. Let's refresh again. Well, it's still pending, but this is how you can scale your service up or down as needed. And if you create auto scaling, that's even easier because you can auto scale using using auto scaling group. So that's the best way I think we should attack ECS. So let's go back. Well, it's still pending. It takes, because I have micro instances, sometimes it takes time, and besides I have a free account, so my assumption is they're not paying a whole lot of attention to these smaller instances. So let's refresh. Okay, there you go. So we have now desired count done, and as you can see, they're all running in our container instances. So again, you can do a little deep dive by looking at each of your container instances if you want to see which task is running and what is the status of each of your containers for that particular task. So you can deep dive and see all the ports and network bindings and etc. log for this particular task. Similarly, you can see the same thing for the other image. And if you go back, you can also do a little bit of deeper dive into metrics like CPU and memory utilization. And again, you can play around by clicking on these things. By the way, the latest Docker, agent version, this is the ECS agent version, is 1.6. So if you have older one, you should update your ECS agent to 1.6. And here is your Docker version. Again, list of all the tasks running, any stop tasks if you have any, and the services that we have running. Okay, so that's a typical workflow of ECS service. Now coming back to this diagram, I just wanted to summarize the learnings that we have in this session in this nice little diagram. So as you can see, in my case, I have 2 availability zones. The top portion is representing a public subnet where you have your proxy and firewall and IDS and stuff like that. These 2 things are represented by a private subnet, and this is what constitutes your managed cluster. And each container instance is represented by this little Docker icon, actually Docker running box, which has two tasks. And in our case, task one is having three containers, related containers, that should live together. And task two has two containers, and so on. And each of the container instances have an ECS agent running. And that's how you control these container instance from your ECS service. And these are some of the main components of an ECS service. So you have an agent communication service, and that's how you manage your container instances. You can use APIs, both in a GUI format or in a JSON format, to define your requirements. There is a cluster management engine in ECS that's running obviously behind the scenes, and you have a key value store that you can use to manage ECS services, but that's an optional. So that's all I wanted to show you in this session. Hopefully you got something out of it. Feel free to send me your feedback. I'll be happy to revise this based on your feedback and comments. Thank you for watching. Take care.